Welcome to DoYouKnow channel. We are always fascinated by the passage of time. It seems that in the blink of an eye, we grow old. In this world, death leaves almost no trace. This raises some questions. What creates time? Can time stop? When did time begin? Does time have an end? To tell the story of time, we must start from the beginning. The story begins in July 2021, in the deserts of Ancash province, Peru. An ancient stone temple that was previously obscure suddenly received UNESCO World Cultural Heritage status. From satellite imagery, the temple is enclosed by 3 concentric stone walls. At the center are 2 concentric circular structures. This temple, called Shankilo, dates back 2,500 years. It was discovered early on, about 200 years ago, by travelers who documented the site. But why was it recognized as a World Cultural Heritage Site in 2021? Because it holds a secret unknown to many. To the southeast of the temple lies a peculiar structure, resembling the crenels of a great wall. People call them the 13 Towers. These 13 towers stand isolated. No one knew their purpose in the past. After nearly a decade of observation, archaeologists finally discovered their use. During the summer solstice, the sun rises behind the leftmost tower. Every 10 days or so, it shifts to the next tower. On the winter solstice, the sun rises behind the rightmost tower. After 6 months, it returns to the starting point of the summer solstice, and so the cycle repeats endlessly, never stopping. This turns out to be a 2,500-year-old observatory, one of humanity's earliest places to connect with the universe. Shangiro Ancient Observatory revealed a profound question. Human awareness of time actually comes from light. Today, we clearly understand the sun and its planets travel through the universe. The sun moves at 250 kilometers per second, racing through space. Planets are pulled by the sun's gravity, moving in spiral trajectories. This 3D motion pattern doesn't reflect the Sun-Earth relationship well. So we return to a flat diagram. Earth orbits the sun in 365 days, 6 hours, 9 minutes, and 10 seconds due to Earth's axial tilt. Different regions experience slight sunlight variations. This creates the 4 seasons. This is humanity's understanding of time. 365 days make a year. A year has 4 seasons. The moon's phases define months. A day includes night and daytime. Without light's changes, we wouldn't know what time is. Broadly speaking, time is the periodic change of light. But this understanding is too simple, too shallow. The universe is captivating because its deeper logic often defies convention. As one of the 20th century's greatest scientists said, "Your understanding is all wrong." Time reached the year 1905. At that time, Europe was rapidly developing railroads and telegraphs. The Swiss Patent Office wanted to solve the problem of global clock synchronization. A young clerk at the patent office, Einstein, began to ponder the relationship between different time zones. Einstein proposed a groundbreaking idea. Time does not have a universal standard. This theory was considered heretical at the time. For centuries, humans believed time was absolute. It was constant everywhere, whether on Earth, on the sun, or anywhere else in the universe. But Einstein argued that time is not independent. Time and space are interconnected. Take the sun as an example. Its immense mass warps the surrounding space-time. When light passes near the sun, it cannot travel in a straight line. Instead, it follows a curved path. Scientists gradually realized that time and mass are inseparably connected. The larger the mass, the greater its influence on light, and the slower time moves around it. This theory was confirmed in 1971 by an experiment. Scientists used 2 atomic clocks. One remained on the ground, while the other flew around Earth on a plane. When the clocks were brought back together, they showed different times. The clock on the plane was 59 nanoseconds behind. This demonstrated that gravity indeed affects the passage of time. From the Earth to each individual, time is different for everyone. However, because human mass is extremely small and our motion is very slow, the time difference on us is negligible. It's almost imperceptible. In the solar system, the sun's mass accounts for 99.86% of the total mass. Thus, the sun governs the time in the solar system. What about other star systems? For example, The closest star system to us, which is 4.22 light-years away, the Alpha Centauri system. This system contains 3 stars. The combined mass of these 3 stars is approximately 2.1 times that of the Sun, since the Alpha Centauri system has greater mass. The second closest star system to us is the Barnard star system. It is 6 light-years away from the solar system. Its star, Barnard star, is a very small red dwarf. Its mass is only 14% of the Sun's. Because of its smaller mass, time in the Barnard star system runs faster than in the solar system. Not just faster, it moves incredibly quickly. Now here's the question. If celestial objects with greater mass make time slow around them, is it possible for an object so massive that it stops time entirely? And if so, what would such an object be like? Scientists believe that it's entirely possible for time to stop. Such an extreme celestial body is a black hole. The gravitational pull of a black hole is immense. It warps the surrounding space so much that even light cannot escape from it. At the center of a black hole is a singularity, also known as a space-time singularity. This is a point where gravity is infinite, and the curvature of space-time is infinite. At this point, time mysteriously comes to a halt. There is no past, and there is no future. With our current understanding, it is difficult for humanity to imagine what truly happens at the singularity. Astronomers have calculated that within our Milky Way galaxy, there are about 100 million black holes. This means that in the Milky Way, there are 100 million places where the pause button is pressed. Now let's briefly recap. Time and space are unified. Massive celestial objects in the universe, due to gravity, distort the space-time around them, and thus make time vary across different parts of the universe. So how did time begin? This discovery, which reshaped human understanding, takes us back to 1919. At Mount Wilson Observatory in Southern California, the world's largest telescope had just been completed. A highly imaginative astronomer, Hubble, was fortunate to be the first to use this telescope with the most advanced equipment, and an ambitious astronomer. 2 key ingredients for success came together, and so the story began. On the night of October 4th, 1923, Hubble discovered a dark spot deep within the Andromeda Nebula. This dark spot didn't look like a star at all. It resembled more of a spiral-shaped gas cloud. Through spectral analysis, Hubble found that this dark spot was over 1 million light-years away from Earth. At that time, this was unimaginable. This distance far exceeded the diameter of the Milky Way. Today, we know that the diameter of the Milky Way is roughly 100,000 to 180,000 light-years. Hubble's discovery indicated that the universe must be larger and much older. Soon, Hubble figured out that the clusters he discovered were actually galaxies similar to the Milky Way. The Milky Way was just a tiny speck in the vast universe. The scale of the universe was utterly beyond imagination. Today, scientists estimate that in the observable universe, there are about 2 trillion galaxies, and the diameter of the observable universe is roughly 93 billion light-years. Hubble continued his research on extragalactic galaxies. He discovered that almost all galaxies were moving away from the Milky Way. This indicated that the universe was constantly expanding. If we imagine the universe as a bubble, this bubble is continuously expanding. If we reverse this process, the bubble would shrink until it becomes a single point. This implies that the universe had a beginning. Calculating the age of the universe is an incredibly complex task. According to observations from the Planck satellite in 2013, scientists believe that the universe is approximately 13.787 billion years old, with a margin of error of 0.02 billion years. We often round this off to about 13.8 billion years ago. This point in time marks the beginning of the Big Bang, which is also the start of time itself. Now that time has a beginning, does it also have an end? Mainstream astronomical theories suggest that time does have an end. And furthermore, the universe will have a spectacular conclusion. The year was 1988. Physicist Saul Perlmutter received a mission to study supernova. A supernova is a star's final act, a violent explosion. At the end of its life cycle, Perlmutter tracked the trajectories of 42 supernovae. When he charted the data, he arrived at an unexpected conclusion. Our universe is expanding at an accelerating rate. No one knows why the universe is accelerating. When we observe the matter in the current universe, we find that it is astonishingly sparse. Most of the universe is vast emptiness. All the stars, galaxies, and black holes combined are not enough to sustain the expansion of the universe. In fact, they suggest the universe should contract, collapsing back to an initial singularity. Visible matter accounts for only 4.9% of the universe's total mass. The universe contains up to 95.1% dark matter and dark energy, which humanity has no understanding of. It is precisely these unknown masses that are accelerating the expansion of the universe. Perlmutter's discovery of the universe's accelerating expansion earned him the 2011 Nobel Prize in Physics. With the story told so far, we can finally discuss the end of time, the ultimate fate of the universe. But first, let me clarify. This conclusion is currently the most mainstream hypothesis about the fate of the universe, not an absolute conclusion. However, this theory is not mere speculation, but is based on scientific observations and calculations. The timeline moves forward to between 1015 and YY seconds after the Big Bang. All the stars in the universe will have burned out their energy. One by one, the stars in the night sky will go dark. Stars will ultimately transform into black dwarfs, dark and lifeless stellar remnants. Their atoms will be tightly compressed together. The mass of these dark stars will be millions of times that of the sun. The universe will appear entirely dark. Does time stop here? No, because there will still be a faint light in the universe. We already know that at the center of every galaxy, there is an enormous black hole. These black holes will devour the black dwarfs in their galaxies. At the moment when such powerful celestial bodies collide, a large amount of luminous glow will form around the black hole. This indicates that time is still progressing. When time reaches YY to 10,100 seconds after the Big Bang, at this point, only photons and black holes remain in the universe. The huge black holes at the centers of galaxies continue to maintain the existence of galaxies through gravitational effects. However, this time, there are no planets in the galaxies, only a large number of black holes of various sizes. The universe has entered the era of black holes, the age of black holes. These black holes will continue to merge. Today, we already observe that when black holes devour each other, they produce a massive amount of light. So even at this point, there is still light in the universe, and time continues to progress. But as time passes, the black holes will also slowly evaporate due to a phenomenon known as Hawking radiation, until one day, black holes no longer exist. When time reaches 10,101 seconds after the Big Bang, as the universe expands, the temperature of space approaches absolute zero. Photons can no longer move in space. The final remnants will vanish, leaving only endless cold and darkness. In a certain sense, the universe has entered eternity. But from another perspective, because photons no longer exist, time has finally stopped. This is the ultimate fate of the universe. No more light. Time comes to an end, and the universe truly enters an era of emptiness, the era of great extinction. Everything our universe has gone through will leave no information behind. Is there any possibility of escaping this fate? There is indeed a possibility. In an earlier episode, I made a show about time crystals. Time crystals may exist across the universe. Interested friends can take a look. Finally, let's summarize today's show. What exactly is time? Time is inseparably linked with light. Time is the periodic change of light. The mass of an object in space affects time. The greater the mass, the slower time will be around it. Time can stop. Time has a beginning. Time also has an end. In conclusion, time is not a constant quantity. It changes depending on the observer, even down to the individual. Each of our times is different. So, can we use the thoughts of ancient Greek philosophers to reconsider time? Time, like numbers, is just an abstract concept. So looking at it this way, time might not exist at all. Alright, that's all for today's show. Don't forget to follow DoYouKnow's channel. We'll talk again in the next episode.